Welcome back. We're going to be talking about atom structure and function over the next 3 videos. Make sure you have some paper and pens to draw along with me. Here we have the periodic table of the elements, and I know you've seen this previously. Elements are atoms with a characteristic structure and a predictable chemical behavior. What does that mean? That means that every time you see gold, it's going to be yellow, and it's going to behave a certain way. It's going to be relatively bendable and melt at a pretty low melting point. Whereas helium is going to be lighter than air and you can fill up your balloons with it. So those are different elements and they have different structure, and because of the structure, they have different properties. Other examples of elements that we're going to be talking about in this class are oxygen, hydrogen, nitrogen. All of the elements are arranged by atomic number, which you can see here in the top left corner. Each element has its own symbol. An atom is the smallest amount of an element which cannot be subdivided, at least in this class. All atoms have a similar structure. They include 3 types of subatomic particles: protons, neutrons, and electrons. The protons are positively charged, P for positive. The neutrons, neutral, and the electrons are negatively charged. In an atom, the protons and the neutrons are in the middle, in the nucleus, and the electrons are orbiting around the nucleus. What is different between atoms of different elements is how many particles they have. In a neutral atom, the number of protons equals the number of electrons, so the positives equal the negatives. If protons and electrons are different, the atom is considered charged, and it is called an ion. How can we predict how this atom will react? We actually have to look at its structure, because the structure informs the function, right? We start by going back to the periodic table. You start with the atomic number, which for hydrogen is circled up in the top left there. That would be atomic number 1. Every element has its own atomic number, and the atomic number tells you the number of protons that that element has. However many number of protons your element has, they're going to go in the middle, in the nucleus. For the electrons, you have to remember that in a neutral atom, the number of electrons equals the number of protons. So in this drawing, we added the electrons in shells around the nucleus. This is a little bit easier to see than a 3D model. But there are some rules that you have to follow when you place these electrons. Electrons fit into these shells, kind of like lanes on a highway. But there are maximums. The first shell can only hold a maximum of 2 electrons. That's the innermost shell. The next shell, the second electron shell, can hold a maximum of 8, and the third shell can hold a maximum of 8 as well. This is because the inner shell is so much smaller, it can only fit 2. The next rule is that we're going to fill these shells from the inside out. So we will fill each shell to its maximum before we go to the next shell. Whichever shell gets filled last is called the valence shell. This is the one that really determines the atom's reactivity. Once the shells are filled, we think of the octet rule, which states that the atoms prefer to have a full shell. Without a full valence shell, the atom is not happy, and he has to look for another atom to fulfill him. An atom that is looking for a soulmate is ready to make a bond and is therefore reactive. So this structure of an atom determines its behavior. Remember, we talked about how anatomy relates to the physiology. Same thing is true here, even in subatomic land. So let's practice looking at the structure of helium and seeing if we can predict its behavior based on its structure. So helium is atomic number 2. What does that mean? That means that it has 2 protons, right? So let's draw a nucleus, and we're going to put 2 protons in it. And remember the number of protons equals the number of electrons in a neutral atom. So if we have 2 protons, we're going to have 2 electrons. So let's go ahead and draw our first shell, and we're going to put our 2 electrons into that shell. Now, if we had more electrons, we would have to go to another shell, but since we don't, the first shell is all we need to draw. So there they are. Keep in mind, although we were drawing these electrons as kind of stiff and static, unmoving on the page, they aren't sitting there. They're actually orbiting around that nucleus very, very quickly. So this is just sort of a snapshot in time that we are recording with where we put our electrons. So we have one shell, we have 2 electrons in it. The first shell can only take 2 electrons, so have we fulfilled the octet rule for helium? Yes, we have. Helium satisfies the octet rule, and so we would predict that helium doesn't really need any other element to be happy. Helium can be pretty happy on its own. And it's true, helium is inert. It does not react very easily with other atoms. You can call him an introvert because he is completely happy all by himself. So helium's structure, only 2 electrons, a full valence shell, makes him not really want to react with other elements. Let's practice now with carbon. Go ahead and pause the video and try to draw this out on your paper by yourself. Leave some room around your drawing and draw big enough that you can work with this later. We're going to be coming back to this in the next video. Okay, so we know atomic number 6 tells us that there's 6 protons. And in a neutral atom, we also know that there's going to be the same number of electrons than there are protons, so we have 6 electrons. So we can go ahead and we can put our 6 protons into the nucleus, and then we can start drawing some shells. The first 2 electrons can go into this first shell. We can't put any more in there because there's a maximum of 2 for that shell. So we have to draw a second shell. Now, how many electrons do we have left? Well, we have 6 electrons total, and we've already placed 2, so we have 4 more that we have to place. So this is what the structure of carbon looks like when we do this sort of flat drawing here. Does carbon fulfill the octet rule? Well, let's take a look. The valence shell is this purple shell. It's the outermost shell. It can have up to 8 electrons, but it only has 4. So is it happy? Not really. Carbon by itself is fundamentally unfulfilled. So what does carbon do? Well, just like people, if an atom isn't happy on its own, it will search out another atom, or maybe even several atoms, to make it fulfilled. Come back to watch the next video in this series, Atom Behavior, Covalent Bonds, to find out what carbon does. Thanks for watching. See you in class.